Hello and welcome back. So we have the operation star is defined on the set S equals A, B, C by star A, B, C, A, B, C. Okay, so again we have A, B, C, B, C, A, C, A, B. Okay, so again determine whether S is closed. Determine whether S is closed under star. Okay, so determine whether S is closed under star. So obviously what we do is we check every single operation: A star B, A star C, B star C, right? And yeah, that's pretty much it. Okay, and then we look at the results. This gives from the table: A star B gives B, A star C gives C, B star C gives A. So, and these all belong to S. So this implies star is, this implies S is closed under star. And you can pretty much solve, the rest of the questions, right? So let us do, okay, let me just show you one more way they could ask questions like this. So sometimes they would give you a set like this: 1, 2, 3, 4, and we define the star operator by A star B equals A plus B minus AB. So the first question says copy and complete the table. And then the second one they now ask you, is T closed? And obviously we can say, so now copying and completing the table. So the table given was we have 1, 2, 3, 4. 1, 2, 3, 4. So 1, 1, 1, 1, 1, nothing here, and minus 1, and then minus 2, and 1, minus 1, and nothing, and we have 1, minus 2, and minus 8. So these empty spaces, we have to fill them. So we have to fill these empty spaces with actual values, and we will use the operator defined here. Okay, so 1 star 1 is 1 from here, so you don't need to do anything. But then there's the empty space here. So 2 star 2, you find 2 star 2, right? So clearly 2 star 2 will be equal to, from here, 2 plus 2 minus 2 times 2. So in this situation, this will be 4 minus 4, which is equal to 0. So we have 0 here. Alright? Similarly, 3 star 3 will be 3 star 3 equals 3 plus 3 minus 3 times 3. This gives 6 minus 9, and this gives minus 3. So we have minus 3. Then 3 star 4. So it just follows, right? So that's basically how you fill the table. So you have 3 star 4 equals 3 plus 4 minus 3 times 4. So we have 7 minus 12, and this gives minus 5. So you have minus 5, and so on and so forth. So you can easily fill the rest, and then you can fill this too. 4 star 3, which is literally going to give you the same exact answer. Four plus 3 minus 4 times 3, and this is also going to give you minus 5. So we have minus 5 here. Okay, so after copying and completing, of course, you can determine whether T is close. And then, so that's basically how these tabular forms of questions will look like. So now let's do more of the inverses. We didn't really get time to calculate the inverse of a binary operation. Alright, so we go back to one of the questions we solved previously. We were given that x star y is equal to x plus y minus 2xy. Okay, now we obviously, so now okay, we want to find the inverse. So find the inverse of x of an element the inverse of star of an element x, which is a real number, right? Stating which element so stating which element of x will have no inverse. Okay, and then find the inverse of 1. So if you have an idea, you can try this out, but then I'm just going to clean this to free up space, right, and leave the expression, so that we are basically going to find the inverse and then determine which elements of that particular x value won't have an inverse, and also find the inverse of 1. Okay, so they said we should find the inverse of x. So we are finding the inverse of x inverse. Now the inverse of an element, like I said, when acted upon, when x, for instance, is acted upon by a star with its inverse. So when we have x star x inverse, the result must be an identity element. So here, let's say let E equal to identity element. Okay, so this must be equal to E. So let us expand this using this. So we have x plus x inverse minus 2x x inverse must be equal to E. Alright, now clearly we need to have E before we can go any further. Okay, So that is why finding E is always the first thing to do when calculating inverses. Alright? So anytime they ask you to calculate an inverse, just know that you have to find the identity element first. So let's do that. Okay. So first of all, x star, the identity element must be equal to x. So this implies x plus e minus 2xe. So I'm basically applying the operation must be equal to x. So we make e the subject from here. So we have e minus 2xe equals x minus x. Factorizing e out, we get this equals 0. Dividing through by 1 minus 2x, 1 minus 2x. Let's close out with this. We have e equals 0. So the identity element is equal to 0. Okay. So now to calculate the inverse of x, x star, x inverse must be equal to e, which is equal to 0. Okay. So then we apply our operation here. So we have x plus y, sorry, not y, but x inverse. X plus x inverse minus 2x x inverse must be equal to 0. So again, we make x inverse a subject because we are looking for x inverse. So we have x inverse minus 2x x inverse. We send this x across to get minus x here. So making factorizing out x inverse, we have here 1 minus 2x, yeah, equals minus x. So again, we divide through by 1 minus 2x, 1 minus 2x. This cancels out this. So clearly, x inverse is equal to this, minus x divided by 1 minus 2x, and that right here is x inverse. Okay. All right. So now, x inverse has been determined. So now the other question they were now asking is that for which value of x will x inverse not exist? Will x have no inverse? Is that possible? Now, since we haven't done functions and the how a function can be undefined and so on and so forth, I'm just going to take it slowly. Okay, so let me free up the space I hope you have understood this up to this point. If you don't understand anything, just leave a comment below and then I will respond to it. So let's write out the inverse. X inverse is equal to minus x divided by 1 minus 2x as found. Now think about it. Let's say if you have 2 divided by 0. If you try this on your calculator, try to divide any number by 0, you find that your calculator will have a problem. It will give you some math error. This is undefined. You can't divide by 0. That's a nonsensical value. It doesn't make any sense. All right. So whenever you have this, we say undefined. This does not exist. It does not exist. Okay. So, and of course, whether it's 2 over 0, 10 over 0, even 1 million over 0, and so on and so forth. They are all undefined. So based on that, the question said, I'm just going to reframe it here. For what x value will the inverse not exist? And when we say a number does not exist, it means it is undefined. So meaning what value of x will make this particular expression undefined. Remember that it is the denominator being 0 that makes the expression undefined. So what we do is we take the denominator and equate it to 0 to find the value of x that will make the denominator equal to 0. Okay, so we say 1 minus 2x equals 0. Then you solve for x, right? So you have minus 2x equals minus 1, x equals half. So this implies that okay, I'm just going to clean the spots again. So this implies that when x is equal to 1 over 2, x inverse does not exist. And you can try it out. So minus x divided by 1 minus 2 half. Do this, evaluate this, and you get minus x divided by, you see, half times 2 here. This cancels this to get 1 minus 1, which is 0. This is non-existent. It doesn't exist, right? So it is only when x is half that the inverse does not exist. All right, you don't have to resubstitute it to confirm this, but then just to, for your own benefit, to prove that you actually did the right thing, you can resubstitute it to make sure that the denominator gives 0. We will do more of these when we begin functions, which will be right after we finish binary operations actually. Right? Okay. So let us do more of this inverse stuff. Okay, and they also said we should find the inverse of 1. So we found x inverse to be equal to minus x divided by 1 minus 2x. So find the inverse of 1. That means we just substitute x equal to 1 here. So this is equal to minus 1 divided by 1 minus 2 times 1. And this gives minus 1 divided by minus 1 minus 2 gives minus 1, which is equal to 1. So the inverse of 1 is 1, which is weird enough. The inverse of 1 is 1. And that's it. Okay. So let's solve one more question. Or maybe a couple more. Okay, so we have a triangle B is equal to a plus b plus 3ab. Of course, where a, b are real numbers. So we need to find a inverse, and again, and state which element of A has no inverse. Okay, now again, A operator A inverse must be equal to the identity element. So first we have to find the identity element. So now we have A triangle E must be equal to A. That's what identity elements do. It doesn't affect what is being operated on. It just spits out the same thing. So we now expand using the expression given. So we have A plus E plus 3AB equals, 3AE. 3AE equals A. So again, we have A plus 3AE equals A minus A. E is 1 plus 3E equals 0, and so E is equal to 0. So identity element again is equal to 0. So therefore, a triangle A inverse must be equal to 0. So we apply the operation again. A plus A inverse plus 3A inverse must be equal to 0. We'll make A inverse a subject again. A inverse is equal to, we are bringing this to the other side to have minus E. Right, sorry. We didn't. So we have A inverse plus 3A inverse is equal to minus A. So A inverse is 1 plus 3A equals minus A. So you can divide through by 1 plus 3A. 1 plus 3A. So cancel this out. So therefore, A inverse is equal to minus A divided by 1 plus 3A. Okay, so this is A inverse. Alright, so now, for what value of A in the second part of the question? Which element of A has no inverse? Remember how we did it? Try to find it and let's see. So let us clean. If you didn't get anything, you can just rewind the video and just play around with the video until you got it. Okay. So for which element of A has no inverse? Again, for which element of A will the denominator go to 0? So meaning we equate the denominator to 0. 1 plus 3A and solve for A. 3A is equal to minus 1. A is equal to minus 1 over 3. So therefore, whenever A is equal to minus 1 over 3, this expression is undefined. Let's test that. A inverse is equal to minus 1 over 3. So minus 1 over 3. Remember, when two minuses come, it becomes positive. Divided by 1 plus 3 minus 1 over 3. This cancels this. So we have 1 divided by 3, all divided by 1 minus 1 is 0. This is undefined. So therefore, when A is equal to minus 1 over 3, when A is equal to minus 1 over 3, A inverse does not exist. And this is right. Like I said, you don't need to do this part. This is just for you to confirm. Okay? Alright, so A inverse does not exist when A is equal to minus 1 over 3. And that's how this question is solved. Okay. Alright, so with this, we've pretty much covered all of the different ways in which WASSCE sets questions on binary operations. So if you have any questions and comments, just leave them below. And if there's something we've forgotten to cover that you want it to be covered, you can just put it there and I'll go through the comments. I will go through the comments and then we will solve them. Alright, till next time, peace.